So in this part of the test, we're going to determine the concentration profile of the species Q. So before moving on, we need to take a closer look into the reaction where Q is involved. And this is where P reacts with the rate constant K2 to the species Q. So the reaction rate of the species Q is given by the stoichiometric coefficient of the species Q, which is positive 1, times the rate constant K2, times the concentration of the reactant, which in this case is our species P, so Cp, elevated to its corresponding reaction order, which is 1, which we have determined previously. So the reaction rate of the species Q is given as the change of the concentration of the species Q with respect to time is equal, as we just determined, K2 times Cp. So the change of the concentration of the species Q with respect to time is going to be K2 times Cp, which we have determined in the previous task, which is K1 divided K2 minus K1 times Ca0 times parenthesis E elevated negative K1 times T minus E elevated negative K2 times T. So we separate the variables by multiplying the equation with dt, which will result in dCq being equal to K2 times K1 divided K2 minus K1 times Ca0 times E elevated negative K1 times T minus E elevated negative K2 times T times dt. So we integrated dCq from 0 to Cq with respect to time. And the right side we integrate from T0, which is 0, to T. So Cq with the lower boundary being 0 and the upper boundary being Cq with respect to time. So this part of the equation does not depend on the time, and it's not a function of the time. So we can move this part in front of the integral. So K2 times K1 divided K2 minus K1 times Ca0 times the integral E elevated minus K1 times T minus E elevated negative K2 times T times dt. So inserting the boundaries, Cq is equal to K2 times K1 divided K2 minus K1 times Ca0 times 1 divided negative K1 times E elevated negative K1 times T minus 1 divided negative K2 times E elevated negative K2 times T, where the upper boundary is T and the lower boundary is 0 for the variable T. So Cq with respect to time will result in K2 times K1 divided K2 minus K1 times Ca0 times negative 1 divided K1 times E elevated negative K1 times T plus 1 divided K2 times E elevated negative K2 times T plus 1 divided K1 times E elevated 0 which is 1 times minus 1 divided k2 times e elevated 0, which is also 1. So at this point, we have already solved the task, but it doesn't look very clean, the equation I mean by that. So I will just give you my notes how to make this equation present it in a more clean manner. So feel free to go through my notes. So this is our simplified form of the equation. Now let's look at its sketch. So for the concentration of the species Q will depend on the amount of the species P, because it's only involved in the second part of the reaction. So at the beginning we have very little P, so the slope of CQ is gonna be very low, and it will increase with time as we have more P, but at some point our P is being converted to Q and we have not so much P left, so the slope will decrease.